now that we've gone through all the basics of a linear function, we're going to go through some practice questions and try to regroup and put it all together. So the first example says find the slope of the line in the graph. And remember, the slope is the change in y over the change in x. So what we want to do is find 2 points on the line and then find what the vertical change is to get from point to point and what the horizontal change is to get from point to point. And I want to recommend that you don't pick a point such as this point right here on the line with the green mark, because I don't know if that's 2.5 or 2 3/4. It's really hard to tell if it doesn't cross exactly at a cross on the grid. So make sure you're picking points that it crosses exactly on the grid, so you're for sure confident in what you know that ordered pair is. Okay, so now when we look at this, I'm going to make like a triangle so I can see what my change in y over change in x is. My change in y is my vertical change. And if I look, 1, 2, 3, it's 3 units up. And my change in x is a horizontal change of 1, 2, 3, 4 units. Now they're both going in the positive direction. So when I go from this point to this point, I'm going to the right, which is positive, and I'm going up, which is positive. So when I take a positive over a positive, I should have a positive slope, which makes sense with the graph because as I trace this graph, left to right, it's going up. So I should have a positive slope. So my slope is going to be the change in y over change in x, which we found was 3/4. In the next example, I can see that this is one of my special cases. When I have a vertical or horizontal line, that's one of my special cases. And if you can't remember if your equation of the vertical line is x equals or y equals, or you can't remember if the horizontal line has an equation x equals y equals, think through it. Don't worry about memorizing things. If I just start picking points on here, if I notice all my y values of those ordered pairs has a y value of -5. So the x value changes, but the y value does not change. So that tells me my equation should be y equals -5 because it's always a y value of -5. Now just a quick refresher, because my y value doesn't change, my slope is the change in y over change in x. It doesn't matter what the change in x is. I'll put a question mark there because it doesn't matter. But because the change in y is 0, my slope is going to be 0. Just a quick reminder of slope of a horizontal line. Okay, example 3 says sketch a line with the given features. We want a y-intercept of 0, 3, and we want a slope of -5/4. Well, if I have a y-intercept at 0, 3, that means on the y-axis, I have a point at 3. So for sure, I know I have that point right there. And then I need to use the slope to find additional points so I can draw my line. Well, I know my slope is the change in y over the change in x. And since my change in y is -5, that means from the point that I know is on the line, I'm going to go vertically down 5. And then since my change in x is +4, I'm going to go to the right 4. So 1, 2, 3, 4, 5, and then over 1, 2, 3, 4. That will give me another point on the line, and all I need is 2 points, and then I can draw my line. There's the graph of my line. Okay, next example, we're given the equation. Okay, we have our equation in mx plus b form. My m is -2. Remember, that's the slope, which is the change in y over the change in x. And my b, which is my y-intercept, is -5. So I know for sure that on the y-axis, this line is going to pass through the point -5. And then I can use my slope, just like I did in the previous example, to find another point in order to graph my line. So we don't write it in there, but we know that there's a 1 under here. So I have the point -2 over 1 for my slope. So that means my change in y is going to be 2, and it's going to go down 2 because it's negative. So down 2, and then my 1 is positive, so I'm going to come over to the right 1, and then there's my line. Okay, example 5, it says sketch the graph of the equation x equals 2. This is one of my special cases. As soon as I see an equation that says x equals and just some number, or y equals and just some number, I know it's going to be either a horizontal or a vertical line, one of my special cases. And again, don't stress and try to memorize, because if you try to memorize it, you're only going to have a 50-50 chance of getting it right. So I don't want to make a guess and say, oh, I think this is vertical, or I think this is horizontal. Use your brain and think through it. I know that no matter what my value of y is, this is saying my value of x is always 2. So no matter what my value of y is, so we can make an xy chart if you want. No matter what my y value is, my x is always going to be 2. So we can just plug in some points there. Doesn't matter what my y value is, x is 2. So then when I plot those points, 2, -1, 2, 0, 2, 3, 2, 5, I can see this is my case of a vertical line. So now I'm positive I've got the right answer because I thought through it instead of trying to memorize it and make a guess. Okay, last example. This is finding, this is a slope problem, but in reverse. Usually we give you 2 points and ask you to find the slope. In this case, it's only giving you partial information, giving you the slope, and you got to find that partial information that's missing about the points. So we need to figure out what this value of y is here. So we're just going to be working backwards on this one. Remember, our formula for slope is y2 minus y1 over x2 minus x1. So if I call this point x1, y1, this point x2, y2, and I know my slope is -5, I'm just going to plug all of that in. So my y2 is 175 minus my y1, that's what I'm looking for. And then my x2, which is 25, subtract my x1, which is 15, and that should give me a slope of -5. So when I clean this up a little bit, I have 175 minus y1 over, and then I have 25 minus 15, which is 10. I am going to now multiply both sides of the equation by 10 so I can clear that fraction. So when I multiply both equations, or both sides of the equations by 10, I'm going to get 175 minus y1 is equal to -50. So now I'm going to subtract 50 from both sides because I'm still trying to solve for y1. And I'm going to get -y1 is equal to, whoops, I meant 175. See, I make silly mistakes too. It happens. Okay, so I'm going to subtract 175 from both sides so I can isolate the -y1. And when I get that, I get -225. And then divide both sides by -1, and I get y1 is 225. So I know what that partial, or that missing piece of information is now. So I know that if I had the point 15, 225, and the point 25, 175, and I took the difference in my y's over the difference in my x's, I should have a slope of -5.